Okay, so uh, Seattle Iceberg Meetup is one of my favorite ones. It's so great to see a lot of people working on Iceberg here, and it was so great to see the three talks before. I'm Vignesh Chandramohan. I lead the analytical frameworks team at DoorDash data platform. I'll be talking about just two use cases where we use Iceberg, and more importantly, I'll be sharing some of the upcoming use cases and some of the things that we still don't have our handle on. This will be a quick one. I know it's like 7:10, so I don't think I'll take a lot of time. With that, let's get going. The very first use case is data ingestion. This is where we started with. We need the data in Snowflake for our downstream, and we used to have native tables. And we had an explicit additional copy that copied that to the data lake tables, and then the downstream data lake jobs consumed from that. This had two problems. One is the additional latency, and then also the additional cost associated with the copy jobs. So from here, where we move to is to directly write Iceberg tables from Flink, and this avoids the additional copy. And Snowflake reads it as external Iceberg tables, and downstream data lake jobs read it as just data lake tables. So this avoids the additional copy, and there are more details with numbers and all that that was presented in the Iceberg Summit earlier this year. If you search for like Iceberg with Flink at DoorDash, you should get the link. This is the second use case. It's the opposite of the first one. We have Spark ETL pipelines that are already writing data in Delta format, and we want that to be available downstream, and some of the downstreams are accessing it as Snowflake tables. And we wanted a mechanism that creates Iceberg metadata on top of this Delta tables. We use a mix of two techniques. Some of the use cases use Snowflake's Delta Direct feature, and some of the use cases uses Databricks' Uniform. In both the cases, the Delta metadata is used, and Iceberg metadata is created asynchronously after that, and the downstream consumes that as an Iceberg table. So this is the second use case that we have in production for quite a bit of time. So with that, let's look at few upcoming scenarios. So the first one is we are looking at development workflows where users, data engineers, create a clone of the tables, maybe one table, maybe multiple tables, and then they work on the clone. They add additional data to that, and when they are done with their development workflow, these tables are discarded. We don't yet see a proper way to do clone. There is branching, and branching could be used, but RBAC is important for us. The users don't have access to the production tables, but they do need write access to the cloned table. Is branching the right way to go, or should cloning be a separate concept? What about RBAC? All of that is something that we still need to figure out. I see some discussions happening in this GitHub issue, but this is something that we are looking at. The second one, we have started to look at this already. I think there shouldn't be any problem for us using this. This is for our data quality scenarios. After the pipeline completes, we want to validate that the data is correct. These validations could be anomaly detection checks, or they could be forecasting checks, and they might check if the data aligns with what we forecasted, or this could be simple threshold checks. After all of that is done, when things are good, only then we want the data to be visible for downstream. For that, we are planning to use write, audit, publish with branches. In this case, RBAC is okay. The only writer in this particular case will be the ETL job that is uh, responsible for producing the data to that table. And we think that write, audit, publish is the right way to go, and we are working on enabling this. Third is streaming. Streaming in general, we see a couple of gaps. Iceberg writing to streaming sinks is fine for both up and only data, as well as tables that have deletes. It does create a lot of these snapshots, and you do need to run maintenance, but there is a solution and it works. But Iceberg as a streaming source works well for the up and only data. But when you have deletes, it fails with cannot process override snapshot. And there are also a few other things like available now of Spark structure streaming was not there. It is appealing for us for a couple of reasons. Pure incremental processing, seamlessly switching between incremental batch versus streaming, and all that. It was not available for Spark streaming. Someone from my team, Alex, merged this PR recently, and it should be available in the upcoming release, and we plan to use this as well. So that is streaming. There are a few more that we are looking at in the future. One is fine-grained access control. Fine-grained access control, very, very briefly, it's certain columns shouldn't be accessed by certain users, or a portion of the rows should only be accessible for a certain set of users, right? So that is at a very, very high level what fine-grained access control is. And this is important for us from a PII standpoint. And I see that there are proposals for this already. This is something that we are looking forward to. The V3 features that were completed, deletion vectors and variants, that is also something that is quite important for us, and we are starting to use them. Variant is important for us because we have downstream systems that are accessing the columns that are of variant type. Without it, we will need to store it as string, and then the downstreams are accessing it as string, and that's not as performant, and based on our testing. With variant, it is better, so that is the reason. And deletion vector, the binary deletion vector is useful when there are a lot of updates happening to the table. One other thing that we see is maintenance operations scalability related problems. We see that when you have a lot of orphan files and you run maintenance operations, it fails. So we are attempting to fix some of those issues, and there is a PR that someone from the team sent. So those are some of the issues. So to summarize, I talked about 2 use cases where we are using Iceberg today, and I also shared some of the upcoming scenarios and the features that are important to us. Now, why is Apache Iceberg interesting for us? We want to build on open standards, and we want multiple query engines to operate on the same principles. So the more things get added to the spec and more the engines are operating on the same set of design principles, it's better for customers like us. That is why it is interesting to us. And as I shared, we have a lot more to do, and we are hiring. Thank you.